All right, it is 3 p.m. So let's begin. First things first, if everybody can put on their cameras. I hate talking to a blank wall. It's not why I started teaching. Also, it's the only time I'll pretty much get to know all of you. Wait for your name attached to you. So, with you and on your names, if you have, you should be prompted when you come into class about your name, everything along those lines. I just ask you that you put your full legal name. All right. If you have a nickname or something totally different that you want to be called, just put it in parentheses. It'll allow me to, I'll look for that first. If it all comes down to just doing attendance on Zoom, it just makes it easier. And then I can separate in Excel parentheses easily. So if you want to be called something different, put it in parentheses. If you want to put at the end, beginning, doesn't matter. I can handle it from there. But if you guys can put a full legal name, that will help me a lot. All right. Now, welcome to Engineering 540. As people slowly come into the class, I'll be admitting them. Did anybody really struggle with getting into the class today? If you don't have a camera, that's fine. No, everybody got in pretty easy, no problems. All right, good. So I am Professor Callahan, Mr. Callahan, Mr. C, something along those lines. I'll respond to any of those three things. All right, so going through with the class itself until the 25th, which when the school will be going into full in-person classes if the professor so wishes. I am one of those professors who will be doing that. All right, so come the 25th of January, unless we get pushed back, we will be in person. All right. I believe that 500 level classes really do, they don't get the full point across online. So we're going to be going to in person. All right. Keep an eye on the schedule. I'm trying to get the room changed. They may already have changed it, the room that we originally signed I didn't like. So trying to get that changed for us so we get a better learning environment. All right. Let us see. Another thing, just a couple of admin stuff to get rid of out of the way. Couple things to do in this class. One, just get here on time. Two, the other thing is that pretty much have Blackboard open in the background. We will be utilizing it in one way, shape, or form. All right. Whether it be quizzes or any sort of information that I'm putting on there that you guys may want to pull from. But pretty much quizzes are going to be utilized on there until we go to in person. All right. So that being said, I'm going to pull open Blackboard and I'm going to show you stuff. All right. So a couple things you'll probably already noticed on the announcement page. We're not having labs until we are actually physically on campus and full person because we utilize the ship. All right. So that's the announcement there. I will be recording every single lecture as far as being online. I think that just because your internet cuts out or anything along those lines, it shouldn't be the fault of you to not get the information provided. So I record every single one of them and then I post them to YouTube pretty much that day. Give me a little bit of time. It may be the next morning, depending. So just be aware with that. All right. That's the benefit of you guys. And they are going to be pretty much, I put them in a playlist, so you guys will be in the 3 p.m. playlist, but you can also feel free to watch the other playlists, which are like the 10 o'clock in the morning and the 11:30 classes. So, and then some people in the morning two classes were having some major issues getting into it, so I opened this up. Make sure you have a SUNY Maritime account for Zoom. All right, that's so that way we can have only authorized users getting in here, and we don't have some randos. All right, and then the other thing is if that's not working, you can try and just go in with a meeting ID and that passcode. All right, so I had those put in as well. All right, next thing, if we go into the modules, a couple of little different things here. All right, every single time we finish a subject, or if we're in the middle of it, or if there's a logical conclusion, I will be posting the PowerPoint to that actual section. So they're going to be found in the PowerPoints folder. All right. Quizzes are going to be found in the quizzes. All right. So the quizzes will be stated like, valves, piping, whatever. So whatever we finish, that's the quiz that we're going to be taking. All right. Important information. There's not going to be too much stuff going in here besides what you see. There is one more form that I have for you guys to fill out. That's going to be done on Wednesday. I have to write that up. So we got the syllabus. We have the remote learning doc, which you all found to get into this class. STCW, which we'll hit next. And then this 540 book. All right. And then finally down here is some extra reading. Anything that I find interesting or want to share with you guys as far as additional information, you open this up, goes to a web page. This is Science Direct. It's a huge amount of, as anybody hasn't discovered this website, it's a great website. It pulls information from different manuals. It pulls information from different textbooks with really great pictures and everything along those lines. As far as, you know, this is today's topic is valves. So I posted something about additional information on valves. So feel free to read that on globe valves and then go from there to find other information out there as far as ball valves and everything like that. You can come up here and click on a check valve, a globe valve, all that kind of fun stuff. All right. So a really good resource for you guys. Were you able to see that other page? Okay, good. Yeah, if you ever find me just talking and I'm not saying anything because I'm muted, let me know. Unmute yourself and yell at me. If you can't see something that I'm pointing at, or if I'm referencing something that the screen share has been paused, let me know. I don't get the most feedback on this page. So just let me know all of that, all right? So speaking of going to Blackboard, you're gonna have to go to Blackboard. Going to have to go to important information, and we're going to open up that STCW. We're going to go over that. All right. The other thing that I need you guys to do is, if everybody is on a actual physical computer, this is only going to help you in the long run. Make sure you go to Adobe. So type in Adobe into Google. If you already have this program on your computer, good on you. All right. So you're going to go to this page. This is Adobe Reader. All right. Make sure you unclick these McAfee. No one needs that on their computer. All right. It's basically a virus. And if you want the Chrome extension, click it. If you don't, I don't care. And then download the reader. All right. The reason I'm doing that is because there's going to be some signable pieces of information that are going to come out, and I'm going to need you guys to sign it. It will just make your life easier and mine. If you want to, you can print it, sign it, scan it, send it, and submit it back. That's fine on you. This is for people who don't want to or don't have the ability to sign in real life. All right. Anything on that? Any questions before I move forward? All right. One person hasn't joined us yet, so I'm going to send them an email. Just so that way they can join. Is he in here? No, he's not yet. Okay. All right, everybody has the STCW page up? All right, so first things first, let me put up the share and we'll go through and read this. So this is an STCW required class. It's a 500 series class for the engineering, basically the engineering side of things. The deck department may have their own form, but this is ours. So if you are in a 2 or 3 credit course, meeting 28 times in a 14-week period, I know we're doing 14 weeks smushed into 13. We're going to stick with the 14 period, so it's better for you guys. So just enjoy that. Don't get technical on me. That will just make it worse for you. All right. Now, you can miss no more than 3 classes. Any more, automatic F. Nothing I can do for you. Doesn't matter if you are a chief engineer and you're taking this class for the first time. Doesn't matter. Coast Guard doesn't care. All right. So excuse absences. An excused absence may be made up in another lab, in a case of machine shop or diesel lab. That doesn't really count for lecture, but those excused absences are medical issues, doctors, if you have a doctor's appointment that can't be moved. Some people had surgery that were upcoming. Obviously, that can't be moved. You do your best to control it, but it's your health. Take care of yourself. Now, going through with that, I need something that says you were there. Doctor's note, not, mom or dad or grandma saying that you had a tummy ache that day, and to please believe them. That doesn't really help. All right. School-sponsored event. So Propeller Club's famous for this, for having events. If you're part of the football team, even though it's spring, I use them as an example because they do this quite often. They tend to have to leave on Thursday nights and they miss Fridays. So just kind of keep that in the back of your head. If you're on a sports team or if you are in some sort of school-sponsored event, we need a higher authority that will allow you guys to basically be able to miss these classes without repercussion. Another school-sponsored event, advanced firefighting, basic firefighting, any basic training, things like that. Mandatory training that you cannot get out of. That was not, you weren't the one who scheduled it, okay? Now, going with that, military training, any NROTC, reserve duty, are you active duty, things like that you just can't control. That is, what you got to do. All right. And then finally, funeral or family illnesses. I hate asking for this, but every single time, get something that, again, higher authority than you saying you're at a funeral. Any sort of the cards, things like that. I will probably 100% believe you, but your grandmother, shouldn't die 3 times during the entire semester. Okay. So make sure you have something of higher authority than you. So that way we're all on the same page. All right. Any other absences is unexcused. So car problems, we don't have that problem right now. Travel difficulties, oversleeping, arriving to class at a uniform, not possessing the proper PPE, not being prepared, being told to leave, arriving class late. All right, so down here is the signature. So you can type your name here. I've made this form signable. And then you can go up, if you look right up here, to this portion right here. Sign the document. I already have my name in here because I use this quite often. And then you can just plop it right in. All right. Make sure you save the document. All right. If you don't save the document, then none of this is going to show up. All right. Any questions? No? Brian, you are really, I can't hear you.
Can you hear me now?
Yep.
Okay, so I heard you say something about like engineering, or if you were a chief engineer. What was that in regards to again? Like
So,
right at the beginning.
Basically with the STCW, and this goes into a story of, I like to tell about this. Last January, I was in advanced firefighting. I was re-upping my license. I was renewing it. All right. In that room with me was the chief engineer of the training ship, the captain of the training ship, the electrician of the training ship, and finally, the man who teaches advanced firefighting on the school ground. Okay? So you have to be in this classroom because of attendance policy by the U.S. Coast Guard. That's what I was referencing, that even if you're a chief engineer and you don't make it to this class enough, you would still fail due to the Coast Guard. The man who teaches advanced firefighting at this school, who probably has the same level of knowledge of the person who is teaching our renewal class, is having to sit in that classroom for a week straight to take a renewal class for his advanced firefighting that he spent all semester teaching. So at this point, it really does not matter what you are, your grades, anything like that. It just matters your time in the seat in the class. Okay?
Okay. Thank you.
Yes, and I agree, Parker. McAfee is terrible. It's a super virus. There are ways, if you do want to get rid of it, there are YouTube videos showing how to seriously delete that type of software. So just for your knowledge, looking out for that. Now, let me see. All right, moving forward, let's go to the next portion. Again, this 540 book is the book that I'm going to be recommending. It's free to you on the whole page. This is a study guide, but it's still a really wealth of information that you can use. All right. Let me open the syllabus and let's talk through the syllabus. There we go. Oh, and by the way, I'm looking two different ways because I'm running two screens. So if you're wondering why sometimes you see this side of my head. All right. So this is the syllabus for this semester. All right. 3-hour class, 1-hour lab, 3 credits. All right. You need this before you go on summer C term. And there is no D or D plus or D minus in this class. All right. This is the required text. I do not recommend it. It's there because I have to require a text. Buy it if you want. I wouldn't spend more than $50, but it's not worth it. So don't get it. Now, going through, we have our instructor information. There's my email. All right. Do not email my student email. I won't answer it. I don't look there. Please don't do that. Office hours are by appointment only. If it's between 1:30 and 2:45 Monday and Wednesday, I guarantee you I will have office hours. You have to just email me. Not like 12 hours. It could be like, can we meet right now? I will be okay. You know, I'm guaranteed I will sit at my computer during these times. I just don't see it worthwhile to have Zoom open during those times waiting for someone to appear. All right. So just email me and I will send you a Zoom link and we'll just pop it open. It'll guarantee that it'll just be you and me. All right. If you can't meet inside those times, special appointment. All right. I'm fine with it. If you want to meet at 5 o'clock at night on a Tuesday, email me. You know, just give me a little bit of a heads up. I will most likely say yes unless I'm in my own class or I am driving in a physical car. Most of the time, I will help you if I can. All right. I met with somebody at 9:30 at night the day before the final. All right. They got very lucky that I was sitting at my computer still doing some work. So days and hours, you can see them right here. I'm trying to change the rooms. I don't like the rooms. So going from there, once that changes, just kind of keep looking at self-service. It will show up. All right. Cell phones, not to be used in this class or any test or quiz for any reason. You all know that there's no self-service out at sea. You can't look up, oh no, a valve is broken. What do I do? All right. So make sure you have your own knowledge. Grading. Everyone's favorite part, grading. Oh, and by the way, like I said, if you're confused about anything on the STCW form or you don't want to do that 10% calculation, it's always in the syllabus for any 500 level class. All right. So right here, it says for our class. Okay. Grading, there will be 3 exams along with quizzes for each section completed. So anytime we finish one of these course outlined sections, it's guaranteed to have a quiz the next class. All right. Let's see, the exams will be classroom during the course time, same with the quizzes, and your participation in lab will be graded. And I will get into that later in the course when we're actually in person. But just know that you're gonna have 10% via a plate, or it's going to be a STEAM tracing. If you were in my class last semester, you're gonna see we're gonna be doing a totally different way of grading rather than what we were trying to do last time. Again, this plate is going to basically be done in lab outside class time. All right. Your lab instructors will help you a lot with that. But again, more on that as we get to in person. All right. Quizzes, take the average of the quizzes. It's worth 15%. Exams 1, 2, and 3, all worth 15% each. Final exam is worth 30. All right. Now, if something bad happens and we cannot meet in person come this semester, obviously we won't be doing 540 lab this semester. We will deal with that if that actually does happen. I hope it does not. Forewarning, this plate will disappear. This 10% will probably be taken and 5% of it will go to the quizzes and 5% of it will probably be broken up to each one of these exams. I'm unsure, but I will probably take care of that and you will know by Wednesday. Okay? But that is a severe backup plan. All right? Makeup policy. There is none. I just won't accept it. All right? Obviously, if you're an NROTC, a funeral, I'm not going to, punch you in the gut just because you're at a funeral. Those things I'm basically going to follow the STCW. If it's an excused absent, you can make it up. If it's an unexcused absent, you're not making it up. Okay? So, final grades. As you see, 69.999 repeating is a F. All right, 70 and above is passing in this class. Here's your course outline. If you want to know really quickly, this is what we're going to be doing for our exam topics. Valves, piping, pumps, and pump ops are all exam number 1. Freshwater generation, refrigeration, HVAC is exam number 2. And electricity and hydraulics is exam number 3. We have 2 weeks, which we do steam plant and shipboard operations, and that's going to go into the final. All right, so that way we can hit into cruise time with the most amount of steam and shipboard thought process as possible. Accommodations. Before we hit accommodations, talk to academic integrity. Don't do it. Just don't do it. All right, so academic learning disability, that whole deal. All right, here's my spiel on it. I'm not responsible for emailing the dean for your academic stuff. Take care of that yourself. All right, if you need it, email them, they'll email me. I can't ask for it. Number 2, I'm not going to deny anybody any extra time or anything that they need with their disabilities. I'm very clear about that. What I will say is Coast Guard doesn't recognize it. The sea doesn't recognize extra time. The sea doesn't care if you need an extra 5 seconds or another time and a half for anything. That's why the Coast Guard doesn't recognize it. All right? Now, that's the reason the Coast Guard doesn't recognize it. Like I said, I will recognize it, but it's with a stipulation. When you take your license, since they don't recognize it, you have the same amount of time as everybody else to do your Coast Guard questions with no, I have friends who had dyslexia, like severe, and he passed his license. He passed 7 for 7, actually 8 for 8, because now we're doing gas turbines. All right, so he was fine. Other people that I know were fine, but what they did was, and this is why I bring this up, is exactly the way that they took care of themselves. They practiced in all of their 500 level classes. They challenged themselves to get the questions done in the time allowed. All right. But what they did was they didn't let their grades suffer if they needed to. All right. They did the questions, and if they felt confident, well, they were done, and they did it in the time allowed. But if you're struggling, use the time. That just means that time you just didn't get it, and that's okay. But you have the time, use it. Okay? That's the thought process behind this. If you need it, use it. But try to push yourself to get it done on the time that is allowed by the vast majority of students. Okay? When we get to in-person, oh, and by the way, make sure you tell me before the day of the test. I can't help you if it's 5 minutes before the test start. I can't help you. At that point, it's whatever. So just give me a heads up. So when we're in person and when we're online, the reason I ask for a heads up is because I put on a timer for everybody. All right. So I'll put you in a special group so that way if you need the extra time, you automatically are given it. All right. So that way you're taken care of on that. Now, when we get into in-person, and for the most part, I have no class after all my classes that I have, with this class on Wednesdays being an exception. Let me just see something. I want to know something real quick. Oh, dang it. I did it to myself. Oh, well. So both the exams, test 1 and test 3, are on a Wednesday. So I need basically to give you guys, if you need the extra time, I would prefer you guys to be with me. But if you have to go to the other people, if you need it, use it. So when you're in the classroom, we could continue to be in that classroom. There's no class after us, probably. I'll double check it. So all you have to do is raise your hand, and I'll stay until you're done with your 1.5 or 2 extra time. All right? So you don't have to go to the special room or anything like that. That way, any questions you have, I can answer them. All right. The person going to be administering the exam, Dr. Anderson, is not an engineer, so they won't be able to help you on the questions if you have a question regarding your questions. Okay? So I prefer if you guys stay in the room with me. All right? That is it on that. A little bit more admin. Monday, January 15th. Sorry, Monday, January 18th, there is no classes. Friday, January 15th is a Monday schedule. All right? So that means we have this class 3 times this week. We have it today, we have it Wednesday, and we have it this Friday. Okay? This Friday is our first quiz. All right? This is your announcement on this Friday being the first quiz. It's 10 questions. It's not going to be that bad. All right. Close these things out that we don't need them anymore. Any other questions regarding anything along those lines?
Professor, I have one more question. So I saw the whole thing with the excused absence. For military orders, like this Friday, I have a problem because I'm scheduled for drills, and now all my classes are shifted to the Monday. So just send you orders, and I could take it at a different time, and that's okay with you?
Yep.
Okay, sweet. Thank you.
Yep. So again, that will be, so he has an excused absence. He'll be fine. The one thing I would recommend is guys, if, like I said, you're fine on that, but I would highly recommend watching the YouTube video of that day's lecture. All right. So that way you don't miss out on anything. All right. Now, the only thing is that I have not figured out yet. I have an idea. I haven't figured it fully out. Is if you pop positive for a COVID, all right, because that has happened to a bunch of people, right? Where your roommate tests positive and then you can't go to class, right? Has anybody had that experience yet or know somebody? So if that happens and we're in person, and there's not going to be any YouTube video to go and watch. So I'm going to have to figure out a way to manage this. All right. I might be live streaming it. We might figure out how to do it. It all depends on what room I'm in. All right. So let's begin today's lesson. Again, not in teaching mode. My throat's so sore. So, again, these PowerPoints are going to be available to you. All right. It's going to be available before the quizzes. It's going to be available before the exams. All right. So that way, don't sit there and struggle to write everything down that's typed on the actual PowerPoint. All right. Make sure you listen to what I'm saying. Make sure you're writing down what I'm saying. Make sure you're writing down whatever I'm writing down. Okay. Those are the important things. That's where the test questions, that's where the quiz questions are going to come from. These PowerPoints are a guide. All right. They're a guide to the lesson. Yes, there's still valuable information in there, but don't stress about writing this down because it's, like I said, it's going to be given to you. Now, we're going into valves. Valve type by function, all right? So these are the functions of valves. They're not the actual physical name of a valve. These valves have, they'll have different valve names like a ball valve or a globe valve or a gate valve, all right? We're gonna get into those today, but what those things do as a function will be different. They're categorized as their functions. So we're learning about those first, all right? So a stop valve, it's closed or wide open to isolate a equipment or a system or route flow. All right. Now you have throttle valves. These things are going to be partially open to control throttle flow. All right. Check valves permit flow in one direction only. All right. So if you have flow going in one direction, it's only going to allow flow going in that singular direction. It's a mechanical device. You cannot control it manually. All right. Stop check valves. They act as a stop valve when closed and a check valve when fully open, maybe throttled to control flow in one direction. We have regulating valves. All right. These can be automatic, and they have to be, to control the flow at one location in the system in response to a signal. All right, this signal can be anything. It could be, if it could be measured, it could be turned into a signal that a regulating valve can decipher. All right, so flow, temperature, pressure, level, anything. Quite literally any single thing that can be measured can be turned into a signal from another portion of a system or a different system. So you could take information from any system and control another system. It could be 2 inches down or it could be 20 feet away. It could be 2 miles away. All right. And these are some examples. All right. And now we have these two types. All right. We have a relief valve and we have a safety valve. And they're brought up together because a lot of people get these two confused. All right. So first thing, relief valve. Both of these are automatic. Let's be sure about that. So relief valves open at a predetermined level above the normal operating pressure to protect the system. So let's say that we have a pressure vessel, right? It wants to exist at 80 PSI. All right. Now, we have a relief valve. Let's say this pressure vessel is just an air compressor tank, all right? And we have a broken air compressor automation. It's just broken. It's just sending air pressure constantly, all right? So we have a tank that wants to be set at 80 PSI without a relief valve. And we have a broken air compressor that's just constantly sending air into this tank. What's going to happen to this pressure vessel?
Gonna blow up.
It's going to blow up. It's going to have a failure, right? So if we're going to have something that's going to have a failure, well, we need something to be able to protect it, right? And that will be both the relief valve and the safety valve. All right. So talking about a relief valve, it will have a set point somewhere in a location that will be a safe working pressure. All right. So let's say our relief valve has a set point of 100 PSI. All right. So that means as we continue to add air into this air tank, into this pressure vessel, it gets from 80, it goes to 90. And then from 90, it goes to 95. And then once it hits 100, it's going to open. All right. And because we're putting in so much air, give me 1 second. Oh, shoot. Yes, it's gonna be posted. So it opens up at 100 because that's the set point. Okay. So because it just opened and there's so much air coming in, it might take a few seconds. So it might even get to 105 and then 110 before it actually starts to come back down. All right. But right at 100, that's when that relief valve opens up. All right. So as we go the other way, and since it opened up at 100, here we go this way. And now it starts to come back down to 105, then 105 to 100. What happens when it goes from 100 to 95?
Does this
Goes-
valve close?
So the relief valve will close. All right. Because remember, its set point is 100. It will open at 100 and it will close at 100. All right. That's all it does. It just opens and closes. Now, same example, but for a safety valve. So a safety valve is similar to a relief valve, but it resets at a pressure below its popping level. So a popping level or something popping with a relief valve or a safety valve is in thought process to its set point. All right. So if you hear someone say it's a slang for, what is its set point? It popped at 100. All right. So we're still going to have a popping pressure of 100 PSI. All right. But we need a reset. So a reset has to be below. So we're going to say our reset is at 70 PSI. All right. So if we have a broken air compressor, again, same example. We go from 80 to 90 to 95, 100. It opens up at 100, so it's opening, right? But it hasn't caught up yet to the amount of air that's pushing into this. So it just kind of sneaks up to 105, 110, and then it starts to come back down because it's starting to overcome the momentum of what the air compressor was doing. Remember, during this whole thing, the air compressor is just constantly running because it's broken, all right? So it's coming down. It goes from 110 to 105, then 105 to 100, and then from 100 to 95. What happens when it comes from 100 to 95? What is the valve doing?
It's going to keep decreasing the pressure till it gets back to 70 PSI.
How is it doing that?
Because, I can't remember. Never mind.
Does the safety valve keep it open?
Exactly. So we continue to write this. So from 100 to 95, even though it opens at 100, its popping pressure is 100. The reset is all the way down at 70. All right. So this valve is open all the way from 100 to whatever highest it goes, but it doesn't reset again. It doesn't close until it gets to its set point. All right. And it's always below its popping level. It could be 5 PSI. It could be not even in pressure. It could be with temperature. So it doesn't matter, but it's a valve that is going to be done via most likely pressure. All right. And the way to think about it is that a safety valve, it's safer. It's going to give you that wiggle room. It's going to give you that tolerance. All right. If this pressure vessel blows up at 150 PSI, all right, say the fittings can't, the area where the pipes connect can't overcome 150 PSI. Well, you don't want it to get close to that, right? So yes, a relief valve will just blow and it will constantly blow at 100. But what will happen is the nice part is about a safety valve is that it'll give you that wiggle room. It will drive it all the way down to 70. And then it will take a while for it to go all the way back up to 100. It gives you just that little bit more room and sometimes just that little bit more time. All right. So it's a safer system. So it's a safety valve. All right. Make sense? Any questions?
I have a question, sir.
All right.
With the safety valves, is there any downsides to using that over relief valve? Is there like a decrease in efficiency or something?
The only thing that would be, oh, and by the way, guys, if you have any questions, don't wait for me to say if you have any questions or anything like that. Please ask. All right. If I'm not seeing it in the chat, someone say something. Now, the only downside would be is that if you need that pressure for something, like if you need that instantaneous pressure, that could be the only thing where I could see this being a problem, where you need 80 PSI. Well, maybe the set point, like the reset, might be 75 instead, might be a little bit closer. All right. So it all depends, but it's one of those things where more than likely, the safety valve is going to be a better valve. All right.
Professor, how does the valve like hold open though? Because I know for a relief valve, the valve's going to be pushed open until it goes below the certain pressure. But how does that valve know it's going to hold itself open until it gets to a certain set psi?
It's pretty much so. Most of the time with everything, it's all springs. All right. A relief valve is going to be operated off of a spring pressure, which is done via some calculation, and then it has a range where you can set it at. All right. Safety valve is going to have pretty much the same thing. All right. Where it will be overcome. All right. The internals are just a little bit more complicated on itself. All right. It could have something in there. It could have a double spring. It could be done where a portion of the spring, once it's getting an elastic point, there's a lot more. It's a lot more complicated. Whereas with the relief valve, it's pretty simple. Where it's just a spring, and then once it can overcome that spring pressure, it overcomes it, and once it can't anymore, it closes. All right.
Okay.
So moving on to gate valves. Let me get a different colored pen. There we go. So gate valves, their functionality is a stop valve. All right. They only go open or they're closed, and that's it. We have a couple pieces here. They're nomenclature that you should know. All right. First of all, we have our hand wheel. That's this thing that we're going to be turning. All right. That will function, and that will either open the valve, lefty loosey, righty tighty. Going to the left will, open the valve. To the right, we'll close it. We have the stem, which is what connects the hand wheel all the way down to our disc. And our disc is this black piece right here that I'm circling. That's the actual physical valve that you see. It looks like a castle gate. That's why it's called a gate valve. All right. And then we have what's known as a seat. All right. This seat is right here. You can see it. I'm kind of trying to highlight it in green. And it goes around the entire thing. That is the portion. It's a metal-to-metal contact where the actual valve, where my hand down here is the seat, and where the disc is coming down onto it. And they will make physical contact. And those two spots are where it's actually going to be sealing on, where the disc moves and actually makes contact with that seat. We have the body of the valve. We have the bonnet. All right. Bonnet's that area right up here. You can see it's going to be the one that houses, The bonnet is what houses the actual gate when it's fully open. We have the stem. I went over that. We have the yoke. All right. The yoke up here basically will, it holds the hand wheel in place. All right. For the most part. All right. And then we have the packing gland. The packing gland is what stops any of the fluid from escaping between the bonnet and the stem. All right, so it has like gasket material, it'll have packing material. It's basically, it stops any fluid from getting out, which you guys will learn more come 542. All right. Now, disc traveled is either greater and or equal to the diameter of the disc. All right, so that orange part moving up is our disc. It's getting out of the way. The height is equal to the diameter. And when it's fully open, it has little resistance to flow. So why would we not want this as a throttle valve? If I move the disc down to here, and we have like a 75% open valve.
Will the pressure break it?
How would it break it?
Shearing pressure.
Bending it?
What was we had bending, and what was the other one?
Shearing.
Shearing? Oops. It's not going to shear it. You'd have a lot of force there if you were trying to shear it, because then every single time you would open and close this, you might shear off and you might snap your valve. That would be bad. It's not going to be shear. If we use the throttle, what would happen over time?
It would bend and it wouldn't sit in the seat.
It's not going to bend.
Would it erode?
It's going to erode. All right. So eventually, over time, this will erode. All right. Now, some may be faster than others. All right. If you are working on a dredge ship and you are using a gate valve to push a slurry of sand and water going through, well, you're pretty much going to be sandblasting this thing 24 hours a day, 7 days a week. All right. It would destroy it in a matter of months, and it would never close properly again. If this was just pure water, pure hydrogen and oxygen, it would take some time, but it wouldn't be months. It might be a couple years. All right. But it would still erode it. Same with air. The more you would add to it, the worse it would get. But it always goes, and it is the same. This will erode. Now, if we look, and we kind of look like we're going to go, I grabbed it wrong. Going to look at it this way. All right, that's the view we're taking in here. All right, so we have in blue right here is the seat that I'm drawing. And then I'll do red to stay consistent. And I'll say this is a very dramatic disc. All right, so this disc can't go any more farther down. It's fully closed. But obviously we can see there is material missing right here in the purple that I'm squiggling in, right? So that's what it would look like in the wear. That could be an inch, that could be a couple millimeters. And what that is called leak by, right? You want these valves to be able to isolate a piece of equipment. You want it to be completely closed. So that way you can remove a pump, you can remove a heater, you can remove things that you're trying to work on. All right. Or maybe you just don't want the fluid to be going that way. So that is what happens. That's what you have that's the leak by. Does that mean that every time you open it erodes slowly? No, it would take so long for that to happen. It would be, I mean, you can say that it would, but it would be such a minute amount that it really doesn't matter. All right. Now, there is an instance where you could put and make this a throttle valve. When would you be able to make a gate valve a throttle valve? What would it look? What would the system look like? What would we have to do?
Are you talking about in terms of protecting that gate?
Not in protecting the. You could protect the gate, but what would you do? What would you have to do for the system? What would you have to do for the gate valve? How would you make it so that way you could use this as a throttle valve? Even though I just spent the last 15 minutes telling you guys that you can't use these things as a throttle valve.
You could open it like halfway.
If you open it halfway, you're still going to get that erosion, right?
Replace the valve and use like a gate, or use a butterfly valve or globe valve?
You could use a different valve, but I'm telling you, there is an instance on the TSES that you can use, and you have to use a gate valve for a throttle valve, but only because the way that it's set up. How would you be able to throttle and also not have any erosion?
The flow wouldn't need to be too great in the first place.
So if you had a very slow flow.
Yeah, that's right.
Okay. So that would work, but again, you would still have a small amount.
Of
And
erosion. Is
remember,
this like, would it, I know this might be stupid, but like with the steam or something? I don't know.
so if you did it on a steam cycle,
Yeah.
it
Could
would
you do it that
still actually would erode it because it would be working at such high pressures.
way? Okay.
Anybody else has a thought?
What fluid are you working with if you're trying to make this
It could be anything. It could be the worst thing. So if you were to take two valves, two gate valves, and put them in line with each other in series, you would have to label one of them as your stop valve or your isolation, and the other one as your throttle. So if you were to take one valve and have it fully open, and now you can take your other gate valve and you could throttle with it. As long as this stop valve never has a problem and is always fully open, it's not going to wear away. And that leads you to be able to throttle with the other valve. Like I said, as long as you have them and they're both designated as that.
That's still going to wear away, isn't it?
The throttle valve will still wear away, but you will still be able to stop the fluid. What if the other side of this is attached to a tank? All right, but you need to throttle the flow with, and the only valve you have is a gate valve. As long as you have one valve right next to it to be able to stop that flow, you can use it as a throttle valve.
So this is just to make sure that if you're using one as a throttle valve, if you mess that thing up to the point where you can't close it, you still have your backup valve to shut the system off?
Exactly. And
Okay.
the stop valve will always be used as a stop valve only. More than likely, you leave this throttle valve in whatever position it is, 75% open or whatever it is. All right? Because the distance between here shouldn't be that large. It shouldn't be like hundreds of feet, because then that doesn't help you at all. You have hundreds of feet of, you know, if that's some really bad oil or whatever you don't want on your skin. All right? So it should be like pretty close to each other. And there is one instance on the TSES where this is used. That's why I bring it up. All right, does that make sense to everybody? Okay, good. So moving on, we have ball valves. All right, so ball valve is functions only closed or wide open. I have a better photo to show you at the end of the class, so hang on. All right, but quick nomenclature. You have your stem, handle, packing gland, your body. It's suitable for high pressure. All right. The other thing about it is whatever way this handle is pointing, and you'll see better in the next slide, is the ability to tell if it's open or closed. So if you spin this handle 90 degrees, you'll go from open to closed. All right. So you watch this animation, and it will also be with the flow. All right. So this handle is going with the flow. It's allowing flow. Now, it is stopping the flow. It's parallel to that, perpendicular to that flow. All right, it's stopping it. All right. Again, the nice thing about ball valves is that it's a 90-degree turn. It's very easy to open these things. They don't have a lot of wear to them. They pretty much will seal pretty perfectly all the time. And the other good thing about them is any sort of, they don't oppose any of the flow. The diameter of this hole is the diameter of the pipe. It's going to allow the flow through it. That's why it's a ball. All right. So that way the blockage can be on the outside. All right. Because if the diameter of the ball was the diameter of the pipe, well, you would have to have a ball that would look about that big. Right. And then all of a sudden you would have a lot of restriction to the flow. All right. We have a butterfly valve. It's a stop valve or throttling function. It utilizes a seat for the first time. It actually uses the seat as a gasket. All right. Still has a body. It has its disc, handle, stem. Kind of looks like a ball valve in its operation with the handle. All right. So right now it's in the closed position. All right. And what we're seeing in the animation right now is it's opening up. Now, the thing to pay attention here is this gasket right here and this gasket right here. If you notice, I drew two lines there because they are not in line with each other. They don't meet up, all right? So one side of this gasket is being pushed up against by the valve seat, right? The valve disc right there. The other one's over here, and it's pushing on it, right? So the more force you apply onto this handle, the more tightly this is going to seal. All right, and you can see it opens up. you're going to have some restriction to flow because it does exist as an oval. It's actually in the middle of the flow. All right. Any questions on butterfly before I go to globe? All right. Globe valves. Now, globe valves are pretty much a hose spigot valve. Every time, if you were to go to a hose spigot, next time, take a look inside of it. Guarantee you it's probably a globe valve. All right. Unless you have one of those new frost-proof ones, then yeah, this is not it. But the nice thing about a globe valve is that it could be a stop valve or a throttle valve. All right. So if you have a hose spigot, right, and you're going to be using your sprinkler, well, do you turn your sprinkler on at full blast every single time? Or do you regulate the flow?
I try to make it so that's not just blasting at the beginning, but it's not too much.
You want it to cover the area that you got, right? And not like
Yep.
get your neighbor's yard. So, well, at the end of the day, when you're done watering, do you turn the valve off and does it leak by for the most part?
Unless I emptied it.
Unless what?
Unless I empty it, like basically have it always over my head and just empty it.
Yes. But if you take but at the valve itself, there's not any leakage, right?
No.
So what's happening there is these valves are great because they take the function of a gate valve, so they don't have as much restriction to flow. All right, so this plunger right here is still going to go into this area up here. All right, but the other great thing is that they have a seat that they go onto. All right, sometimes they will have a gasket. They'll have a gasket where I'm drawing in green right here. And if that wears out, then there's nothing you can really do about sealing. But if you have one that's a metal-to-metal contact, all right, which I'm going to show you in the next slide after we get through some nomenclature. If you have a metal-to-metal contact one, which will basically be a matching flange, so you have one right there, and those two angles match up to each other. Well, the more you push down on it, the higher chance those two angles are going to meet up and seal, right? So if you have a side that's like this and like that, and that's our two seats, let me change our color for the disc. So originally our disc would seat up and mesh right there, right? But after it's worn out because of we throttle it, well, the disc is a little bit smaller. So we have to push it down a little bit, right? We push it down like that. Well, it still ends up, still pushes down, and it's going to make contact with those seats because they're both on an angle. It's going to meet up the farther down it goes, right? The only thing that just stops that ability is that on the seat itself, there may be some cracking or some damage there. But for the most part, if your disc is the one that's wearing and not the seat, this thing's always pretty much going to seal. Again, like I said, if there is a gasket there, then there's really nothing you can do. But if it's metal to metal, you're in luck.
Do you need to replace the disc?
Sometimes you'll have to replace the disc. Actually, more likely than others, you can actually machine the seat and take a little bit of material off and it will seat perfectly. But if you're having a problem or any leakage, you can remove the top bonnet here. You can see that this is threaded right here in this area. So you can remove that part, all right? And then you'll be able to pop this entire top off and you'll be able to see if that gasket is needing replacement. All right, most of the time there will be like a bolt right here and it will hold on the gasket. So going through, here is all of our nomenclature. All right, I'm not going to go through it every time. You can look at it. It's the same nomenclature as last time. Everything exists where it all is. You just have to know where it is. All right. So this is what I was talking about as far as the next picture. You could see that this angle here, I was just about to point to my screen. No one's here with me. So you have a angle here, all right, and this angle here. They're going to meet up with each other. All right. So if this has a little bit of wear right in this portion, well, you still have the rest of that surface you could push down on it and it will seal. All right. All this math I don't care about, by the way. None of that matters. So they come in different types and styles. All right. So you can see this one's a little bit of a vertical with a 90 on it. This one has a weird little dance to it. They just come in different styles. Not all the time will it look exactly how you see it in the Coast Guard drawings or anything like that. All right. But just know if it's coming from below and then it goes out that direction, it's a globe valve. All right. Now we have our swing checks. Swing checks can be mounted horizontally or vertically. You could see this isn't the greatest drawing down here, but if you look and use both these drawings at the same time, that blue area, not the one that I drew on, let me use a different pen. This blue area right here is the actual swing. All right, it's the same as this red area that I'm circling right here. So because that swing is where it is and where it's pivoting, it's using gravity to close it. All right, the actual spot where it's seating is what I'm going to draw in purple. This green area right here and this purple area right here. Those two spots, the same thing. That's what's actually closing and physically making contact. Okay, so the red area that I traced out is what allows it to be hung vertically or horizontally. They just can't be done upside down because then it wouldn't work. But this allows us to actually utilize gravity and flow in order to control our flow. All right, so if flow is going in the direction that I'm showing with our arrows right here, it's going to flow fine. It's going to push open this gate and it's all good. All right, but if we switch the flow around to, let's go green, this way. Well, one, gravity is going to close this swing check, right? And two, same with this pressure. It's going to catch this and it's going to push it closed. All right, so if the pressure can't overcome this swing check, it's not going to open up. All right. Now, you want to think about that as we go into this horizontal mounting only of the lift check. All right. A lift check uses a plunger. So you can see the plunger that I'm highlighting in green right here. All right. It's very mechanical. It rides on this area that I'm kind of coloring in. So if you were to mount that in a vertical position, well, gravity is going to be affecting it in this way and it's never going to close, correct? So flow goes this way, it's going to overcome gravity of the force of gravity on this plunger and it'll allow it to pass. All right, so as soon as that flow can no longer overcome the force of gravity, well, it's going to close. And then as soon as the flow goes in the opposite direction, well, it's going to hit that plunger, and you better hope that it's already closed from gravity. And if it's not, and it's coming back, that's going to close it. All right. So that's why it can only be done in a horizontal mounting. If it's vertical, it wouldn't work. All right. Now we have a stop check valve. And this is using a globe valve tendency, but it operates as a check valve. If you notice, these two aren't physically connected. They are gliding up and down on each other. So it allows for fluid to come through if it has a high enough pressure to go up to this point. The nice thing about these things is you can use them as a throttle valve also, because it's a globe valve. So, and it will still operate like a stop check. All right, again, because it's using the plunger style, it can only be mounted horizontally, not vertically. All right, stop check makes sense? Okay, good. Valve system nomenclature. We have isolation valves. All right, this is a pump right here. That's a symbol of a pump. All right, we have a suction and discharge. So Suction and discharge are in reference to the pump, the system, the equipment that it is a part of. All right. If I put another pump right over here and pop in 2 more valves, what is valve number 1? Is that a discharge or a suction?
Suction.
It's a suction, right? Because it is in reference to the
To the pump.
equipment. Exactly.
Yep.
To the equipment it's servicing. All right. Doesn't matter that there's another pump over here. Just because it's the discharge of this pump means that all of a sudden you now have a discharge again to another pump. That wouldn't make any sense. All right. This is now your suction. Moving through, we have a fuel oil heater. Well, a fuel oil heater doesn't suck or discharge. It has an inlet and an outlet. All right. It's the inlet to your equipment. It is the outlet to your equipment. All right. That's what's in reference to. And as we come through, we have a meter. This meter also has an inlet and an outlet, again, in reference to its equipment. All right. And then we have what's called root valves. All right. So we have our root valves to our burner. This is our fuel oil service for our boilers. All right. Here's our 4 burners. All right. And this is the actual tracing of our ship. All right. And then the next class, we're going to be getting into control valves and all that automation. Discard that. Let's go here, open up this thing, go over to this, and pop this open. All right. So I just typed in gate valve into Google to get a couple of different things for you guys. Now remember, gate valves, whatever distance, however large they are, is the distance they will have to travel to go fully open or fully closed. All right. If you have a 6-foot gate valve, it's going to have to travel 6 feet in order to go from fully closed to fully open and vice versa. All right. Now you can see here is a couple of variations. This one has a motor on it. Now, the big thing is here is you can see this hand wheel, right, is almost looks like it's detached to the stem, correct? What's happening is that the hand wheel stays put, and what is going on is it's sitting on a bearing, and as you spin the hand wheel, the only thing allowed to travel is the stem because it's a screw. All right, so it's pulling the screw up. All right, so that's a rising stem. All right, now if you look here, the hand wheel and stem are attached to each other. And if you go into your basement or your garage or wherever you have your water heater today, and I encourage you to do these things, especially now since you're home, you can look at your own home equipment. All right, you could see this is most likely what you will have downstairs or in your garage, wherever you get your hot water from. All right. This stem is attached to your hand wheel, and as you open it, the whole entire hand wheel moves as you open up that gate valve. So if you have a 3/4 inch gate valve right here, well, this stem is going to move up and down 3/4 of an inch. All right. Remember I told you we'd have better pictures of ball valves? You can just go through them really quickly and look. This one's going to be open. That's closed. This one's open. Open, 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 open. All right. And you can see just by looking at their hand wheels where they are. That one we can't even see internal, and we know that's open. All right. If we looked at this, if we couldn't see that inside, we wouldn't know if this is open or closed. Hell, it's 50% open. All right. So we can actually see on this photo that why it's an actual ball valve. You can see the ball with the physical hole in it. It's actually a cylinder that goes through the middle of it. And when it's closed, that ball surface right here where my arrow is what actually is going to be showing itself and be physically closed on it. Okay. There's another version, stainless steel version. All right. You can see as it's closing, as the ball, the cylinder portion right here is going to be where it is right here. All right. Now, anybody have any questions? We have a couple minutes left.
I just wanted to say, my schedule got switched around a lot, so I went into another class because that's originally what I had, and I came late to this one. And also on Blackboard, it says 540-1. Is that a problem, or because this is obviously -3?
Okay, so you made it into today. All right, so you're fine for today. Don't worry, just
Okay.
the Monday morning. The Wednesday 9 a.m. class. Sorry,
Okay.
10 a.m. class.
Okay. What I was asking is there like a Blackboard? Is there like a separate Blackboard site for like section 3, or is it all the same?
Oh, you got switched from lecture 1 to lecture 3.
Yes. Yes.
Okay, so the system should pick up.
Okay.
I'm not going to have any difference in it, and until Friday's quiz, will there be a real problem? Okay. So if you're
Yeah.
not switched by like Thursday night, email me.
Okay. Thank you.
Double check with everybody. Everyone's in a 540 lab, right? Okay, good. Y'all should be. Last thing, all the questions, and I don't think I mentioned this to this class. All of the questions are going to come from me as a person. All right, so I'm going to be writing them all. They're not going to be the Coast Guard questions. All right. I do believe I'm going to stop recording.